Solar flares are explosions on the sun. They release huge amounts of energy. This energy travels through space at the speed of light. Solar flares are the most powerful explosions in our solar system. Imagine 1 billion hydrogen bombs exploding at once. That's the power of a large solar flare. These flares release energy across the electromagnetic spectrum. This includes X-rays, gamma rays and radio waves. Solar flares happen near sunspots. Sunspots are cooler areas on the sun's surface. They are caused by intense magnetic activity. When this magnetic energy is released, it creates a solar flare. The sun's activity follows an 11-year cycle. During this cycle, the number of sunspots and solar flares increases and decreases. We are currently in a period of high solar activity. This means more solar flares are likely to occur. Scientists classify solar flares based on their strength. The smallest flares are B-class. They are relatively weak and have little impact on Earth. C-class flares are more powerful than B-class flares. They can cause minor disruptions to radio communications. M-class flares are even stronger. They can cause brief radio blackouts and affect satellite operations. The most powerful flares are X-class. These flares can release enormous amounts of energy. They can cause significant disruptions to technology on Earth and in space. The largest solar flare ever recorded occurred in 2003. It was classified as an X-28 flare. This flare was so powerful that it overloaded the sensors used to measure it. Earth is protected from the worst effects of solar flares by its magnetic field and atmosphere. The magnetic field acts like a shield. It deflects charged particles from the sun. The atmosphere also plays a crucial role in protecting us. It absorbs harmful radiation from solar flares such as X-rays. This prevents the radiation from reaching the surface. However, Earth's defenses are not perfect. Powerful solar flares can still cause disruptions. They can interfere with radio communications and GPS systems. They can also damage satellites and power grids. When a solar flare erupts, it can also release a coronal mass ejection, or CME. A CME is a giant cloud of plasma and magnetic field. If a CME hits Earth, it can trigger a geomagnetic storm. Geomagnetic storms can have spectacular effects. They can create stunning auroras, also known as the northern and southern lights. However, they can also cause widespread power outages and disrupt communication systems. Scientists are constantly working to better understand solar flares. They use telescopes and spacecraft to observe the sun and track solar activity. By studying solar flares, scientists hope to improve our ability to predict them and mitigate their impacts. One important area of research is space weather forecasting. Just as meteorologists forecast weather on Earth, space weather forecasters monitor the sun for signs of potential solar storms. This information is crucial for protecting astronauts, satellites and power grids. Another area of research is the development of new technologies to protect us from solar flares. For example, scientists are working on ways to harden power grids and communication systems against the effects of geomagnetic storms. Understanding solar flares is essential for our modern technological society. As we become increasingly reliant on technology, the potential impacts of solar flares will only grow. By continuing to study the sun and develop new protective measures, we can help ensure a brighter future for humanity.